Good morning. In this session, we evaluate a primary non-rechargeable cell referred to as the dry cell Leclanche. The dry cell Leclanche, as the name alludes, is a simple dry cell that could be held by a clenched fist, which refers to as the clench. In this case, therefore, the dry cell Leclanche has three main components. It's made up of an anode composed of a carbon rod which is dipped in manganese 4 oxide paste. It is also made up of a cathode composed of a zinc can, which is similar to the outer casing of this gadget. Thirdly, it is made up of an electrolyte, and an electrolyte is simply a liquid conductor. In this case, the electrolyte is a buffer solution of zinc chloride and ammonium chloride. The buffer solution simply acts in a case whereby whenever it meets a cation, it will be able to neutralize it, and when it meets an anion, it will do the same. When it meets an acid, it neutralizes it, and equally, when it meets an alkali, it neutralizes it. Therefore, it is referred to as a buffer or conjugate solution. Let's take a look at this in greater detail. The dry cell Leclanche, as we have said, is of three main components. And the first component we have said is the anode, made up of a carbon rod which is immersed in manganese 4 oxide paste. This carbon rod has been immersed in a paste of manganese 4 oxide. Secondly, there is a brass cap which increases the sensitivity for the cell to be able to transmit charges. The brass cap is identical to a conductor. Thirdly, we have the cathode, and the cathode, as you can see, is represented by a zinc can. This zinc can has an inside compartment made up of the electrolyte. The electrolyte in this case is a buffer solution, as we have said, a mixture of zinc chloride and ammonium chloride. How then do the reactions in the dry cell proceed? For the dry cell Leclanche to undergo a chemical shift, the main reaction begins at the cathode. So we look at cathode reaction, and we realize that the cathode reaction simply is a process whereby there is the zinc ions precipitated by the process of oxidation. Now, once the oxidation process has occurred at the cathode, the anode reaction will proceed, simply because there are no free delocalized electrons in space. Rather, the electrons which are found are obtained from other elements. In this case, therefore, at the anode, we happen to have what is referred to as the ammonium ions. The ammonium ions in the solution shift to the anode, and when they meet the two electrons that have been precipitated at the cathode, they are relatively reduced into ammonia gas, hydrogen gas, and in that process, we refer to it as a reduction. So during this reduction process, we can see that the electrons which were precipitated at the anode have been transferred at the cathode have been transferred to the anode, and they have been used to reduce the ammonium solution into two respective gases, namely ammonia gas and hydrogen gas. Once this reaction has occurred, we find that the hydrogen gas which has been precipitated would combine with the manganese 4 oxide readily, and when this hydrogen gas combines with the manganese 4 oxide, it will precipitate manganese and deposit water. In that respect, you will find that the cell will be wetted, and if it remains in that state, it will no longer be in use, simply because the cell reactions will be assumed to have been depleted. However, the ammonium gas, in this case the ammonia gas, which is in the solution, will proceed to meet what we are calling the zinc chloride, which happens to be in the electrolyte solution. When the reaction occurs, a complex is formed in the form of tetraamine zinc chloride. This tetraamine zinc chloride is complex and irreversible. The state of being irreversible renders the cell depleted. And when the cell is depleted, it means therefore it is non-reversible. The non-reversible nature of this cell makes it a non-rechargeable cell. Therefore, we refer to the dry cell Leclanche simply as a primary non-rechargeable cell. It's dry simply because it is non-rechargeable. What have we said about this cell? We have said that this is a common cell referred to as the dry cell Leclanche. Leclanche is simply a description of the clench, that you can hold it as a clench on the fist. Two, we have seen that it is made up of three components, mainly carbon rod immersed in manganese 4 oxide as the anode, zinc can, which is a plate representing the cathode and carries the electrolytic solution, which is a buffer mixture of zinc chloride and ammonium chloride. We have said that the main reaction begins at the cathode, where there is a reduction oxidation process in which the zinc can dissociates to form zinc ions and gives out 2 electrons. The 2 electrons are then transferred to the anode, whereby they meet the dissociating ammonium ions in the electrolyte. The ammonium ions are therefore reduced by the electrons from the anode, from the cathode, and when they are reduced, they end up forming 2 gases, mainly ammonia gas and hydrogen gas. The hydrogen gas proceeds to be oxidized by the manganese 4 oxide paste at the anode and forms liquid water. The final reaction is when the precipitated ammonia gas meets the electrolytic solution composed of zinc chloride and forms a complex salts, namely the tetraamine zinc chloride. At that juncture, we realize that the cell reactions have come to a sudden halt and the cell is said to have been depleted. Simply because it is not reversible, we say that this cell is non-rechargeable. In the next clip, we are going to analyze in detail these chemical reactions of the dry cell Leclanche. Thank you.